Universal joints can usually consist of two yokes, also known as forks, and a central cross-shaped element. When a cross is used, there are typically roller bearings or bushings required to install the cross. If the cross is built from a block and pins, there are ways to avoid bearings or bushings, but they can be added as well. A cross and roller bearing design is shown on the left. You can see a pin and block design on the right. There are also ways to add roller bearings and bushings to a pin and block design, as shown in the middle of your screen. The contact surfaces between the yokes and the central connector are what transmit the torque and motion, and therefore must carry considerable loads. The design and type of connection in these spots are critical for optimizing the performance of a universal joint. These spots are called bearings. There are two major types of bearings for a joint: plain bearings, also called friction bearings or bushings, and needle bearings, also called low friction bearings. Both plain bearing and needle bearing designs have their advantages. Plain bearings are usually simple, cost-efficient, and can carry relatively high loads at low bearing speeds. However, they tend to be more difficult to lubricate, and heat generated by the friction can be a problem down the road due to wear or galling. Plain bearings can be adapted to the application by the materials used, such as alloys, stainless steel, and a combination of harder and softer materials like brass, bronze, or PTFE coatings. The needle bearing design generates less heat and therefore can operate at a higher RPM, but at a lower loads. They can also be sealed and permanently lubricated. Now, once you've identified the best bearing design needed for your application, there are many options to choose from for connecting the shafts to the yoke of the joint. The ends of the yoke that connect to the shaft are usually referred to as hubs. Some of the most common hub features are shown here, but there are many other variations and additions possible according to each application requirement. The next two slides show some of the specialized hubs we have created to meet customer needs over the last few years. The assemblies you see on the top left and top right offer female bores with a spline on the outside hub. The top left assembly features a male shaft on one end and has been turned down to a smaller diameter, while the other end is a flange connection. This assembly was used to steer an unmanned robotic transport vehicle. The assembly on the bottom left is a joint used in aircraft high-lift actuation systems. The assembly you see on the bottom right is used in the paper manufacturing machinery. The far left joint on this slide utilizes keyless bushings inside the female end. This joint was used in a vacuum application that manufactures computer chips. It also has a special protective boot that we designed and made from 316 stainless steel. The two central custom hubs feature split hubs. In a split hub design, the shaft are usually inserted into the split hub and a collar is added to the outside of the hub to be clamped down over the split hub, securing it in place on the shaft. The second joint is a small joint used in a medical application that requires the female hub to be split. The third joint is used in a bowling alley pin setter. To the far right is a joint used in a remotely operated vehicle for the offshore oil industry. It features a female bore on one end that attaches to the remote operated vehicle's tool, and then the square end is used to actuate the valve. You will notice the spring secured over the center area of the joint. This was designed to allow the assembly to remain straight or return to the zero position on its own so it can be easily inserted into the valve while underwater.